Now let's take more examples on trigonometric equations. We recall that all we just have to do while solving the trigonometric equations is to find the value of theta ranging from 0 degrees to 360 degrees. So now let's have another example. Let's call this question number 3. The question says we should find the value of theta between 0 degrees and 360 degrees that satisfies the equation of 6 sine squared theta, okay, plus sine theta minus 1 to be equals to 0. So we have this expression or this trigonometric equation of 6 sine squared theta plus sine theta minus 1 to be equals to 0. Now let's solve this together. To solve this looks in like a quadratic equation. So let's say let P be equals to sine theta. So if P is equals to sine theta, we will have that 6P squared, because when we rewrite this expression or this equation, we will have something like 6 sine theta squared plus sine theta minus 1 is equals to 0. So if P is equals to sine theta, we will have 6P squared plus P minus 1 is equals to 0. Now we have the opportunity to solve this in a quadratic equation. So solving this in a quadratic equation, we can resolve it to give us 6P squared plus 3P minus 2P minus 1 to be equals to 0. So factorizing the first two terms by 3P, we will have 2P plus 1. Factorizing the remaining two terms by minus 1, we will have 2P plus 1 to be equals to 0. So in essence, we are saying that 2P plus 1 multiplied by 3P minus 1 is equals to 0. Therefore, 2P plus 1 is equals to 0. And as well as 3P minus 1 is equals to 0. So we can find the values of P here. P will be equals to minus 1 over 2. Likewise, P is equals to 1 over 3. Positive 1 over 3. Now, let's recall that the first thing we did when we had this expression was that we let P to be equals to sine theta. So we are saying that P, which is equals to sine theta, is equals to minus 1 over 3, minus 1 over 2, and likewise P, which is equals to 1 over 3, is equals to sine theta. So we have sine theta is equals to minus 1 over 2, likewise that sine theta is equals to 1 over 3. Now we have this now. The question now is, where is sine theta negative and where is sine theta positive? We go back to our expression on tangents. In tangents, we have the first quadrant where all are positive, second quadrant only sine, third quadrant only tangent, and in the fourth quadrant only cos. So this expression here is x is equals to theta. Here we'll have 180 minus theta. Okay, here we'll have theta plus 180 degrees, and likewise here we'll have 360 minus theta. So moving on, let's find the value of theta where theta is negative. What quadrant is it where theta is negative? So theta is negative here in the third quadrant and in the fourth quadrant. So we have third quadrant and fourth quadrant. And theta is positive in the first quadrant and also the second quadrant. So we have the first quadrant and also the second quadrant. So with this, we can find the expression of theta. Theta will be equals to arc sine of 1 over 3. Arc sine of 1 over 3 will be equals to 19.47 degrees. Now this is an expression in the first quadrant. Now in the second quadrant, we will have that the formula for the second quadrant is 180 minus theta. So simplifying that, we will have this possible value of theta. Let's call this theta 1. Let's call this theta 2 to be equals to 180 minus theta. And this will be equals to 180 minus 19.47, which is equals to 160.53 degrees. So we have theta 2 to be equals to 160.53 degrees. Similarly, let's do the same thing here. we have an expression of theta. So theta in this place now, theta will be arc sine of -1/2. If you use our calculator to evaluate the arc sine of -1/2, we will have the formula of -30 degrees. -30 degrees. -30 degrees falls in the fourth quadrant. So because it is negative angle. So to get the positive angle here, let's just assume that we'll be using 30 degrees. So to get the positive angle that falls in the fourth quadrant, we'll be using 360 degrees minus 30 degrees, which is equals to 330 degrees. Similarly, we have evaluated for the fourth quadrant. Now let's evaluate for the third quadrant. In the third quadrant, we have the expression of theta plus 180 degrees. So in the third quadrant, we have theta plus 180 degrees. Remember, it is a negative angle, and in the positive angle, we are considering 330 degrees. But in the real sense, the acute angle is 30 degrees. So this will be 30 plus 180 degrees, which is equals to 210 degrees. Now we have four values. Okay, we have theta 1 to be equals to 19.47 degrees, theta 2 to be 160.53 degrees. Let's call this theta 3 and let's call this theta 4. 330 degrees and 210 degrees. So we have the possible values of theta to be equals to 19.47, theta 2 160.53, theta 3 210 degrees, and theta 4 330 degrees. So yes, we can see the beauty in solving trigonometric equations. Now there is just technicality in it, but all we just need to do now is to understand the concept of the quadrant. Where is sine positive, where is sine negative, where is tan positive, where is tan negative, okay, and also where is maybe cosine positive and where is it negative. And with the full understanding of this concept, we'll be able to solve the equation adequately.